Hello and welcome to this Vishay Precision Group webinar on element 14 entitled The Art of Current Sensing. My name is Kevin Smith and I'm joined today by my colleague Richard Zorat.
Hello, how are you doing?
Just a quick note about our company. Vishay Precision Group was formed in 2010 as a spin-off from Vishay into Technology. Our website is www.vishaypg.com. And please go there for more information about all of the products that we will present today. Next slide, please. In this webinar, we will discuss the techniques required to achieve precision current sensing. Current sensing requires a variety of solutions based on the application. And typically, high precision resistors that are used for current sensing are usually of low ohmic value and are suitable for 4-terminal or Kelvin connection, which we will discuss shortly. Other requirements, such as high stability and short thermal stabilization time, are also important in precision current sensing applications.
Just to add in there just for a second, though, current sense measurements are almost always very, very low values in the milliohm range. Lead resistance affects TCR, PCR, and thermal EMF. So as a result, all measurements must be 4-wire Kelvin. Next slide.
Okay, so here we see the diagram of a Kelvin connected resistor or resistor with 4-terminal Kelvin connection. And what we can see is that there are 4 connections, as the name implies. 2 terminals, called the current terminals, are used to conduct electrical current through the resistor, while the voltage drop V is measured across the other 2 terminals, called the sense or voltage drop terminals. So in the diagram, the current terminals are A and D, and the volt drop terminals are B and C. The reason for doing the application like this is so that we sense precisely the voltage across the resistor element itself without taking into account any voltage drop in the current leads. Since the input impedance of the measurement equipment used to measure the voltage is of high value, almost infinity in most cases, this means that there will be almost zero current flowing in the voltage sense leads and hence no voltage drop or almost no voltage drop in these voltage sense leads, which means we are detecting precisely the voltage drop across the resistor element.
Yes, exactly. The meter input resistance is usually 10K meg or better, which is in series, directly in series with the leads, in series with the sense leads of the resistor, and effectively negating any kind of effect by the leads. And of course, the measurement points start at point B and C, which is directly across the resistor element and only the resistor element. Next slide.
Okay, so why use Kelvin connections? Of the commonly used methods of measuring the magnitude of electrical current, this current sensing resistor method provides the most accurate measurement. According to Ohm's law, V equals IR. The voltage drop measured across a resistor is proportional to the current flowing through the resistor. With the known and stable value of the resistance R, the volt drop sensed on the resistor indicates the intensity of the current flowing through it.
Yes, everything Kevin said, and the Kelvin connection also minimizes or negates the effects of thermal EMFs caused by the long leads, but we'll talk more about that later on. Next slide.
In this slide, we show the construction of a bulk metal foil resistor. On the left-hand side, you can see that we use a special layered construction, which consists of the resistor element itself, which is made from bulk metal nickel chromium foil, which is then bonded to a ceramic substrate. If we look on the right-hand side, we can see the production method of the bulk metal foil. It is rolled from an ingot of pure nickel chromium, and this foil is then used to produce the bulk metal foil element and the bulk metal foil resistor.
Yes, what we've managed to do is balance or match the coefficients of expansion of the different materials. It ends up with a very, very stress-free, very, very stable, and very, very accurate resistor. Next page.
Here we see on the left-hand side an explanation, or this side, sorry, is about the unique trimming method that we use to attain the value required. On the left-hand side, you see a top-down view of a typical foil resistor element. Once the foil is bonded to the substrate, it is photo-etched to produce the resistive pattern, which you can see. In addition, trimming tabs, in this case on the right-hand side, and shown in zoomed-in detail in the diagram on the right, are also part of the resistor pattern. When these tabs are removed, current flowing in the resistor element is forced to take a longer route, and thereby the resistance of the resistor increases. And by this process of removing these trimming tabs, we introduce different amounts of resistor element, and we trim up to the desired value, the value of the resistor ordered by the customer. And this means that we are able to trim and produce resistors to any value resistance within the resistance range for a particular resistor. We are not limited to standard values. We can provide resistors to any resistance value within the range.
Just to add to what Kevin said, the actual resolution on these foil images can come down to a few ppm of whatever normal value. All foil resistors have a self-canceling serpentine pattern that is neither inductive nor capacitive. Go ahead, next page.
Specific applications require current control. Dynamic current control, where the current is constantly changing, is more demanding than steady-state current control. Dynamic current control requires the use of resistors with a very fast response.
For control circuits, foil resistors have a very fast, if not instantaneous, thermal stabilization and response. It is an ideal application for a foil sense resistor. Next page.
Okay, on this slide we're looking at the two reversible changes that can happen to real-life resistors due to the effect of temperature, ambient temperature, and also power in the resistor. When high precision is required, these two effects of a change in the resistor's element's temperature due to a change in ambient temperature and temperature change due to self-heating should be considered. These two effects of resistance change are quantified as the TCR, or temperature coefficient of resistance, expressed in ppm per degree C, and power coefficient of resistance, or PCR, expressed in ppm per watt. So these are, just to recap, these are the changes, TCR and PCR, in the resistor's value due to a change in the ambient temperature and due to a change in the power in the resistor. And obviously for precision current sensing applications, it is advisable, if not essential, to use resistors with very low TCR and very low PCR in order to minimize these effects.
Just an interesting side note, thick and thin film resistors permanently shift value after being exposed to a large temperature excursion or power. It's a permanent shift, and it will happen initially and continue to happen every time the resistor is exposed to the phenomena. Next page.
Okay. In the previous slide, we looked at TCR and PCR, which are short-term reversible changes. In addition to that, all real-world resistors are subject to long-term stability or long-term changes in their resistance value over time. This is known as the long-term drift or long-term stability, and as I said, it is an irreversible change. Clearly...
Oh, I'm sorry. Go ahead.
Clearly, it's advisable to choose resistors with very good long-term stability or very low long-term drift in order to minimize the change in resistance of the resistor in the application. And here we're talking about potentially several thousand hours or several years in operation.
This is one of foil's biggest advantages over all other resistor technologies. The end-of-life tolerance for a foil resistor is at least an order of magnitude better than other technologies. Next page.
Another important characteristic to consider when choosing a resistor for a precision current sensing application is thermal EMF. Thermal EMF is a voltage actually generated by the resistor itself due to a temperature difference across the resistor, and it's specified in volts per degree C. It's actually due to the Seebeck, or caused by the Seebeck effect, because of the dissimilarity of the materials used in the resistor's construction. However, this is an unwanted DC offset voltage error and will lead to, or can possibly lead to, an inaccurate calculation of the current. The reason is that in the application, the current, say, has increased to a certain value, and we measure the voltage expecting that to represent exactly the current, but what we don't want is any additional voltage generated by the resistor itself due to thermal EMF, which then would become an error, and we would not be able to differentiate it from the voltage measurement of the current. So we would have a current reading which would not necessarily reflect the actual current. Therefore, for precision current measurement, it's advisable to choose current sensing resistors with a very low thermal EMF.
Just to briefly add, this is a very important and often overlooked consideration for precision current sense applications. I keep talking about this, but we have a video that will point this out at the end, or closer to the end, and it is an extremely important consideration for all current sense applications. Next page.
ESD is relevant to resistors in that it's not commonly recognized, but thick film and thin film resistors are highly susceptible to ESD damage at relatively low levels of exposure, around 3 kilovolts. This ESD damage can occur either during assembly and test, or it can appear as latent ESD damage, for example, due to lightning strikes or other external events, or once the equipment is installed in the field. ESD damage in the production, as I said, can be an issue, but it's normally covered by good ESD protection, which is normally the case these days. And obviously you can protect your circuit board with external ESD protection, which is always advisable, but there can always be the possibility of ESD getting into the equipment, and in this case it's advisable to use resistors with very good ESD immunity. And our Vichy foil resistors are rated at a very high 25 kV of ESD immunity, and this means that they are unlikely to be damaged by typical ESD events, unlike thick film or thin film resistors.
Again, just to add, this is an unseen danger. Thin film resistors can actually be damaged during manufacturing and appear to function okay, only to prematurely fail after installation and a relatively short use. It's an insidious danger. We actually have a video that is very, very good about this. It's on our website, and it points out and shows how easily it is to damage a thin film resistor, shows the actual damage, and gives an indication of what can actually happen down the road to that particular part. Next page.
As Richard said, this is a very important issue, and we have a lot of information about this on our website. We have technical notes, and also the video that Richard mentioned is shown at the bottom. If you go to our website, click on the video section, you will be able to find that video.
Again, please watch the video. It's a very, very good video, and it shows the actual damage and the situation that can actually cause it. Next page.
Another potential issue for power current sensing applications, particularly those which will be installed in the harsh environments, such as alternative energy or industrial applications, is known as the flower of sulfur. And this is the possibility of damage to the device, the resistor, when it reacts when lower layers of silver react with sulfur in the atmosphere, or especially in high humidity sulfurous applications or in atmospheres. In order to solve this problem, the bulk metal foil resistors have a special coating that is proven to be reliable in extreme conditions and even against sulfur. Next slide, please. Okay, and finally, for the discussion about things to watch out for, if you like, when looking at parameters of power current sense resistors, one is harmonic distortion. Harmonic distortion is a signal distortion caused again by the resistor itself in response to an applied voltage. And this depends to a large extent on the construction of the resistor. And bulk metal foils have a very linear response in this respect, much more so than other types of resistors.
And just to add to what Kevin said, foil's continuous homogeneous material characteristic is its big advantage in this respect. Next page. Okay.
So, summarizing those features that we've just talked about, and looking at the key features of foil current sense resistors, we can see that our resistors perfectly meet the requirements of power current sensing. If we look at the parameters shown on this slide, we can see that we offer extremely low temperature coefficients of resistance with our products nominally 0.2 ppm per C over a wide temperature range of -55 to +125 with a reference at 25, with a maximum 1.8 ppm per C. Our power current sense resistors are available in a wide range of values from 0.5 milliohms to 10 kiloohms. They're available with Kelvin connection to very tight tolerance of 100 ppm or 0.01%, and with excellent load life stability, which is down to 0.005% for operation at 70 degrees and rated power for 2,000 hours. All of this means that we are able to offer customers end-of-life tolerance or total error budgets in the range of less than 0.1%.
Just to add everything that Kevin said, and not to keep talking about this, but it's very, very important, is it has a very, very low thermal EMF characteristics of less than 0.1 microvolt per degree C. And we'll talk about that more later on. Next page.
So those were the characteristics of foil resistors, which are extremely relevant to power current sensing. But in addition, if you like, you get additional benefits from our products. And here we see these benefits listed. So first of all, we are not restricted to standard resistor values. You can order any 6-digit resistance value for any of our resistors within the resistor range on the datasheet at no extra cost or delivery time. We also have, by the way, no minimum order quantity and no minimum order value. We've already mentioned that ESD is good up to 25 kV, very fast rise time, very quick thermal stabilization, a non-inductive, non-capacitive design, very low voltage coefficient, extremely low current noise, and as Richard just mentioned, a very low thermal EMF.
The only thing that I would add to this slide is, in actuality, the thermal stabilization is almost instantaneous for foil resistor in almost every application. Next page.
Okay, excuse me. So now we're going to look at a few of the application areas that we normally see either existing or as emerging applications for power current sensing. Obviously, we have switching and linear power supplies and power management systems and power amplifiers. Maybe they're existing more traditional applications. But we also see now a lot of emerging applications, particularly in medical, automatic test equipment, downhole equipment, high temperature electronics, commercially and military avionics for precision current measurement. This is because more and more equipment manufacturers want to know about the efficiency of their equipment to meet international standards for efficiency, but also to have more precision measurement of the current. For example, in medical applications such as scanners and medical imaging, the precision of your current measurement directly relates to the resolution of the final image. Okay, so now we're going to look at a few of these applications in a little bit more detail. Next slide, please. The lithium-ion battery charging and battery management is a critical issue, and is a critical safety issue, as we know. And the lithium-ion battery charging process goes through several critical phases to ensure the battery is charged to its maximum capacity, while at the same time following certain safety rules to avoid explosion or fire. Lithium-ion battery chargers require accurate current and voltage settings and monitoring, as well as a constant current and constant voltage. If these accurate requirements are not met, the charger will undercharge or overcharge the battery. A failure to completely charge the battery results in reduced battery life, while overcharging can cause batteries to fail due to overheating.
This is a perfect application for Vichet foil. Its stability and its accuracy. In lithium-ion charging circuits, even a 1% charging error can result in a catastrophic battery failure. Next page.
On our website, we have a document showing 10 case studies of how customers are actually using today precision foil resistors to improve the operation, flexibility, longevity, and safety of lithium-ion battery charging applications.
We have a new video coming out very soon. Matter of fact, I had hoped to have it ready for this webinar, but we didn't quite make it. It is specifically about this subject, about charging lithium-ion batteries and how to monitor the charging levels and its relationship and how to use a Vichet foil resistor. Very, very good video. It will be on the website very, very soon. Next page.
Okay, now let's have a look at a medical application, which we have a customer who's designed in one of our current sense resistors into a 3D medical imaging application. The requirement was for a 4-terminal 1-watt resistor, and we've offered our VCS1625ZP. The TCR is 4 ppm per degree C, and the tight tolerance is 0.1%. As you can see on the slide, the working power is 1 watt. And the absolute requirement from the customer was to have a less than 5 ppm per degree C TCR over temperature range 30 to 50 C. Okay, next slide, please. Here's another example of a medical application, which is for an X-ray generator for a CT system. The customer required us to provide a current sense resistor with 25 milliohms resistance, ambient temperature range 20 to 35, an absolute tolerance of less than 0.25, and an absolute TCR of less than 10 ppm per degree C. Next slide, please. Another existing and rapidly developing and emerging application is alternative energy. So here we're talking about solar power or wind power. And we have an example here of a customer who was designing power generation, a new generation power supply, DC-DC converter, and modular data acquisition system. The design engineer needed a current sense resistor to accurately measure the output current and provide current sense at a precision voltage divider.
I'm sorry. These alternative energy applications are ideal for foil resistors because of their inherent robustness and reliability. And typically, they're used in remote locations be it solar energy or wind energy, where access and repair is difficult or impossible.
Okay, now we're going to talk about the actual Vichy foil resistor power current sensing product range, starting with our surface mount current sensing power resistors.
I'm sorry, Kevin. Are you done? I'm sorry.
Yeah, go ahead.
Okay, yeah, I'm sorry. Yeah, that's a picture of the CSM3837P. That's one of my designs for an even higher power and more robust version of the CSM. It worked out very nicely. You see there is the heat sink on top of the resistor element. The foil current sense resistor is based on our expertise in stress analysis and proprietary methods of manufacturing 4-terminal resistors. Their use of Z-foil technology allows them to achieve very low TCR, PCR, virtually no thermal EMF over a very wide temperature range. Next page.
Next slide, please. Thank you.
I'm not seeing SMT current sensing foil resistors.
Yeah, we're on the slide entitled SMT current sensing foil resistors, and this slide shows a table of the surface mount resistors that we offer for this application. Here we can see that the power range available is from 0.25 watts right up to 40 watts with a resistance minimum and maximum resistance range of 1 milliohms right up to 10 kiloohms. We can also see here the TCR typical is extremely low, in the range of 0.2 ppm per degree C up to 20 ppm per degree C, depending on both the resistor type and the resistance value. In order to check the actual TCR for a specific model of resistor and resistance value, please check the data sheet for more details.
Just to add what Kevin said, right, the general data sheet. Please visit our website. All this information is there, available at a glance. We have an excellent website, and it's very, very simple and very, very easy to use. Next page.
Okay, now we'd just like to highlight a few of the key products that we have for surface mount power current sensing, starting with our VCS1610Z, which is a 4-terminal Kelvin connection resistor. The power rating is 0.25 watts at 70 degrees C. The TCR is extremely low at 0.2 ppm per degree C nominal. The resistance range is from 300 milliohms to 10 ohms. And the load life stability is extremely good at 0.02% at 70 C for 2,000 hours and rated power. Next slide, please.
I just want to add, add real quick there. This is our high precision current sense resistor with Z-foil. Notice TCR and the other specs are the same as our typical surface mount high precision surface mount units. It's a very, very good unit. Next page.
Okay, here we have the VCS1625, which is rated at a power rating of 0.5 watts, again at 70 C. Is available in the resistance range from 10 milliohms right up to 10 ohms. Has a very low TC of 2 ppm per degree C nominal, and is available in tolerance down to 0.1%.
Yes, this is a slightly looser spec than the other unit, but one of our most popular resistors. Next page.
Okay, and here we have our CSM family, which consists of the CSM2512 and CSM3637. These are available in resistance ranges from 1 milliohm up to 200 milliohms, and power rating is 3 watts with current up to 54 amps. Again, we have a low tolerance of 0.1% and a TC of 15 ppm per degree C.
The CSMs are very popular units. They're available in a variety of sizes and even come in a mill-qual version. Notice the notches in the terminations that we use to create the 4-terminal connection, which is essential for a low-value current sense resistor. Next slide.
Okay. Now we would like to look in a little bit more detail at some of our leaded current sensing resistors. So we have obviously two different families of current sense resistors, the surface mount, which we've just seen, and also the leaded products.
Just to add what Kevin said, we also offer through-hole, these through-hole high current sense units with typical Z-foil performance characteristics. These units have extremely good thermal efficiency, very well distributed internal heat, very low thermal EMF, and extremely fast thermal stability. Next page.
First of all, I'd like to mention our new generation of power current sense resistors, or current sense new generation. And these are custom high power designs which we can develop for your specific applications. We've introduced this family of products in order to offer customers very short thermal settling time, extremely good long-term stability, high powers up to 20 watts, while still maintaining very low absolute TCR of 0.5 ppm per degree C.
Yes, the CSNGs are our newest addition to stable of resistors. These provide the highest degree of performance and precision. These new units use multiple matched foil resistors, foil chips internally, resulting in a current detector with a precision of a few ppm within a fraction of a second of applied power. These are very, very nice units. Next page.
Here we see three examples of our leaded current sense resistor product family. The first one is a current sense new generation. These are real products made for real customers. The first one is a 5 milliohm resistor with a maximum TCR over the range 20 to 60 of 20 ppm and is rated at 2 watts. Then we show our one of our standard products, which is the VCS332Z, in a 1 ohm value with 2 ppm TCR, again at 2 watts. And finally, another current sense new generation product with 40 milliohms, only 1 ppm per degree C, and running at 16 watts on a heatsink at 60 degrees C.
Again, please visit our website. All of these specs and tolerances are available there, and it's very, very, very informative. Next page.
So in addition to the current sense new generation products, we have obviously a range of standard current sensing resistors, and I'd just like to take a few slides to highlight some of the key products that we have. The first one is the VPR221Z. As you can see, this is in a leaded package, again 4-terminal, with a very low TC of 0.2 ppm. It's rated up to 8 watts on a heatsink in a wide range of resistance values from 500 milliohms to 500 ohms, and is available as a screened version in accordance with EEE and MIL specifications for space and military requirements.
Just to add what Kevin said, the VPR221 is a mature product that I've used many, many times for many years for a variety of solutions in anything from aerospace to medical applications. This is a very, very good unit. Next page.
Our VFP3 and VFP4 power current sensing resistors offer power up to 10 watts on a heatsink, very low tolerance of 0.01%. And I keep mentioning tolerance, but this is really one of the advantages of foil resistors, is that we are able to offer these very low tolerances even on low value power current sense resistors. This is something that is unique for our products. And again, here we see a typical TCR nominal of 2 ppm and a resistance range of 50 milliohms right up to 80 kiloohms.
Just to add what Kevin said, is the P3 and the P4 are higher power foil units, and he mentioned the tighter tolerance on these units. This all helps and lends to being your end-of-life tolerance. If you start out with a very, very much tighter tolerance resistor, obviously over time it's only going to drift a little bit anyway, but your end-of-life tolerance is still very, very tight. Next page.
Here we see our VCS 331 and 332 power current sensing resistors. These are 10 watt, again, 10 watt resistors, available in the resistance range 0.25 to 500 ohms, but in this case with a very tight TC of 1 ppm per degree C nominal, with extremely good load life stability of only 100 ppm.
Yes, the 331 and 332 are just another higher power foil unit with even higher degree of precision than the P3 and P4. Next page.
And here we have our VCS 301 and 302 power current sensing resistors. These products are again 10 watts, but are available in the lower resistance range of 5 milliohms up to 250 milliohms, and have a TC of 3 ppm per degree C nominal.
Yes, the 301 and 302, yet another example of precision foil power unit with typical foil performance characteristics.
Okay. We offer precision current sense resistors with custom screening, QCI, and derating, modeled after EEE and MIL specifications. For example, our VCS 1625 is available as the 303119 current sense resistor in a value range 10 milliohms to 10 ohms, and is tested to MIL PRF 55342. Our CSM style resistor is available either as part number 303144 or 303145 in the value range 2 milliohms to 200 milliohms, and is tested to MIL PRF 49465 and MIL PRF 55342. These are obviously additional screening that is done in the factory for these products for military and space applications.
Just to quickly add to what Kevin had said, we offer this PMO, which is short for post-manufacturing operation, on all of our products, and I strongly recommend it for an even higher degree of confidence and performance from our parts. Next page.
Okay, just a quick cautionary note. As we know in the world today, there are counterfeit products around, and we have to, of course, recommend that if you purchase, or when you purchase Vishay foil resistors, you only purchase from authorized suppliers, and those companies, those agents and distributors can be found on our website. We can also say with confidence that due to the technology involved, our experience, and all of the technical know-how that goes into making foil resistors, which has been built up over 50 years now, it's also very difficult, if not impossible, for a company or a pretender to offer something approaching the performance of a true foil resistor. So just a quick note about that, and there's information about this issue on our website if you follow the link on the page.
Just to add again, Vishay foil has been around for 50 years. I'm probably the last of the original Malvern engineering group, and I've been closely involved with this product for 40 years. It is an excellent product. You buy Vishay foil and you get the best there is. Nothing else comes close. Don't settle for less. For more information about our complete line of bulk metal foil resistors, please visit our website.